All right, so here's our first example for part 2. So we are looking at audio tech, so it's a real world example. What it says is, during a concert, a directional microphone was placed facing the audience from the center of the stage to capture the crowd noise for a live recording. The area of sound the microphone captures can be represented. Here's our equation. R equals 3.5 plus 3.5 sine theta. Suppose the front of the stage faces due north. Really, all of that, other than the equation, is fairly irrelevant. So the first thing you want to focus on is the fact that it's a sine graph instead of a cosine graph. Means it's going to be symmetrical with respect to pi over 2, which means the table that we need to create is going to be from negative pi over 2 all the way to pi over 2. So if you just go along and then you just follow all the pieces, so pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and then pi over 2. You are going from negative pi over 2 to pi over 2 because that's where you will see that symmetry with respect to that line. Whereas if it's cosine, you're doing from 0 to pi. So those were those two differences that we saw in that key concept right prior to this. So let's go ahead and plug this into your calculator. I have already done it, so you can either pause right now and work on it, or you can follow along with what I did. But you see that you get 0, 0.5, 1, 1.8, 3.5, 5.25, 6, 6.5, and 7. So those are all our pieces that we are going to pull. So I'm going to go ahead and start graphing them. We are going to 7. So if we just go ahead and consider each circle on our polar grid to be actually a 1 unit, we're going to be going all the way out to a 7 at pi over 2. So we will take a look at 1, 2, 3, 4, 5, 6, 7. So that's going to show where the furthest amount is that we're going to go. And then let's go ahead and graph the rest of the pieces. Pause, because I'm going to go ahead, pause my video, graph it. So in a couple seconds, everything will come back graphed to keep this video a little bit more brief. But I do want to make sure that you guys are trying to do this on your own. And graphing it, and then coming back and checking your work. All right, so here are our points. So we're going to go ahead and we're going to follow that shape around, kind of create that curve. And since this is symmetrical with respect to that pi over 2, everything on the other side is going to be matching that. So we can go ahead and mirror everything and mirror that shape. I'm going to grab a couple main points that will kind of give me that piece that I need. Sit on that whole piece. Just kidding, go back. Let me go further into there. It's this one. And keep going a little bit. So you'll see kind of like mirroring it symmetrical. Mine, obviously one half is going to be identical. The other half, you can make it identical by mirroring it exactly onto the other side. But while we're first getting started in this stuff, you can go ahead and kind of guess the accurate pieces all around. Okay, so that is the shape. I'm going to tell you what kind of shape it is. This is a new shape. This is a cardioid, for lack of me pronouncing things right. It creates a heart shape. So all of you med-term, medical pathway people, cardio, cardiac, all of that stuff that connects back to the heart. So there's a connection for you. Now we need to see what the polar pattern tells us about the microphone. So the polar pattern is actually going to tell us the furthest distance away that the microphone will pick up sounds. So it will be 7 units away because it goes to that 7, and that's in the straight direction. So straight looking out, say this is the stage, and that's the microphone, so that'll pull out 7 units away, depending on what your units are. And then it's going to go 3.5 right and 3.5 left. And that's all we have to do for this one.